Hi, I'm John Bailey, gemstone artist and founder of the Faceting Academy. This is my design, the Fast Barion Square. This design is really great for higher refractive index materials like sapphire. Here's a simulation of this design in darker sapphire. Here's a simulation of this design in demantoid garnet. And here's a photograph of this design that I cut in moissanite. So without wasting any more time, let's get into how to sequence this thing. How do you cut it? Because it's really easy. It only has the same number of facets as a standard round brilliant, and it cuts about as fast as the standard round brilliant. Today we're going to sequence the Fast Barion Square. This is a fourfold mirror image symmetry. It's cut on a 96 index, and it's 4 angles for sapphire and higher, for a little bit higher refractive index material. So the first thing is it's a fourfold mirror image symmetry. When we go to GimCAD, it defaults to 8, so we want to make sure and set that up for 4. When we look at the cutting instructions to set up the pavilion, facet number 1 is cut to temporary point are the instructions. So we're going to cut a temporary point on these indexes at an angle of 43.5 degrees. So 43.5 degrees on an index of 3, that's going to give us the initial base and define where that temporary point is going to exist. We could click here and do meet, or we can click a facet and say copy the z-axis intercept to make sure that we're going to meet where this crosses the z-axis, and I find that faster, so that's how I do it. So 43.5 degrees, where the next facet's on an index of 9. 43.5, index of 9, and that'll meet in the center. The third index is 12. 43.5 degrees, index of 12, and we'll cut that one. Make sure we tell it intercept the z-axis, and that gives us our meets in the center. There's our temporary point, and that sets up our geometry. So girdle 1 says calibrate size. The instructions are to calibrate the size. So if you're going to cut a calibrated stone, this is the step where you do that. On the 96 index, we're going to cut a 90-degree angle. We're going to pick our location, angle of 90, index of 0, and now we've cut a calibrated square. If you were doing a physical stone and you wanted it to fit a setting, you could check it with your calipers at this point and make it fit. The next thing we want to do is girdle facet number 2. That's going to establish our corners on an index of 12, and the instruction is to even the girdle. So to make things clear, let's label our existing facets. That's facets number 1. This is girdle number 1, and we want to meet where girdle number 1 meets the corner. This is the corner guide facet right here, this facet along the corner. So where that meets girdle number 1, this location here, which is this location right here. That's what we're going to use to cut our angle of 90, our index of 12 across the corners. That's going to complete our perfect geometry, a perfect pavilion geometry, and that lets everything else fall where it's supposed to. So this is girdle facet number 2. The next instruction is for facet number 2. This is going to meet at facet number 1, girdle number 1, and girdle number 2. Facet number 1, girdle number 1, and girdle number 2. That's this location right here. That's where you're going to meet. I'm going to use that point to cut. The angle is 69.7 degrees, and the index is 0. So that creates facet number 2. And you can see how the pavilion is taking shape. The only thing left is to cut this point out and install our mains. The mains are facet number 3. They're cut on an angle of 42.5 on an index of 6. The instructions are to meet at facets 1 and 2. And the only place where that makes sense is this location right here. So that's where we're going to do it. We're going to meet at that location. We cut an angle of 42.5 on an index of 6, and that drops in facet number 3, completing the girdle. So from here it's all pretty easy. We transfer the stone, we're going to cut step style crown. We're going to meet here. The instructions for that are set girdle width. So however wide, however fat we want that girdle, that determines how far down we're going to come along here and create our meet point or our location. 41 degrees is the angle. That cuts our initial crown facet. That's facet number A. We're going to meet the corner right at the girdle. The instructions are make an even girdle. So on an index of 12, we're going to go 3 degrees lower than this. So that's 37 degrees. And that's going to allow us to bring this corner facet in a lot more easily. We're going to zoom in on the crown so we can see it better. And I'm going to come less than half of this distance. We're going to leave a pretty large table on this particular design because that's what it likes. It's going to use to cut that location. The angle for facet number C is 35 degrees on an index of 0. That gives us crown facet C. This one was B. Now we're going to do D. We're going to meet where A, B, and C come together right here in the corner. We know that's going to be an index of 12, and it's going to be 3 degrees lower than C. C was cut at 35, so the angle is going to be 32 degrees. Again, we're going to go less than all the way to the top of this, about the same width as facet number A. So we're going to stop fairly low here on facet number C. Pick that point used to cut. We can still go back in and label this was D. That crown angle for facet number E is 29 degrees. 29 degrees on an index of 0. That's the final crown facet. We're going to do the corner. So those are an index of 12, and it was 29 degrees, so we're going to drop it by 3, which is 26. So this is facet D. This is facet E. The only thing left is the table, and we're going to make those star facet, the star row, nice and narrow. So we'll use that to cut. We're going to do an angle of 0. That drops the table in place. We can label it if we want to be real sweet with our design, and zoom back out to get the foreview. This is the Fast Barion Square. You can see it's relatively fast to cut in GMCAD and pretty fast to cut in the real world. It has the same number of facets as a standard round brilliant, produces a nice brilliant stone, and we'll go back to the simulation. This is a simulation of this design cut in moissanite. I hope you enjoy cutting this design in sapphire or demantoid garnet or whatever high refractive index material that you enjoy. And please come back to the site, leave me some comments in the blog area. I'd love to know your experience cutting this design.